Alright, so the video for today will be on graphing radical functions, and this is going to be part 1 of 2. So, let's look at the parent function of a square root. This would be the function f of x is equal to the square root of x. That's what its most basic graph looks like. And then the actual graph itself would start right here at the origin. If I can draw a dot on the screen. There we go. And it's just going to shoot off to the right, kind of like that. And that's what the basic parent function is going to look like. The endpoint of our graph, which would be the origin right there. I know the dot is very sloppy, but it's supposed to be right there at the origin. So that would be the point 0, 0. The domain, as you should know, is always going from left to right. And so it would be all of the x values. It's supposed to be a curly bracket. All of the x values such that x is greater than or equal to 0. You could also put the bracket 0 to infinity. You could also put that. Now the range is always going from down to up. So for this one, you actually want curly bracket, all of the y values such that y is going to be greater than or equal to 0. And for this one, you could also put 0 to infinity. You could put the same thing for the range. So that's the square root. Now on to the cube root. So for this one, it would be f of x is equal to the third root of x. And now this graph is essentially going to look like the one up here, only now it's got an extra part added onto it. Because we're going to start at the origin and shoot off to the right, and then it curves right here at the origin and goes off to the left. So it has this kind of S-shaped looking thing. So right here at the origin, right there, that is what we call the turning point, because that's literally where the graph changes direction. So right there at 0, 0, the domain is actually going to be all the real numbers, because going from left to right, it's forever going in this direction and forever going in that direction. So all the real numbers. The range is also all of the real numbers, because even though it looks like it's stopping right here, it's actually forever going upward and forever going downward. Alright? So now let's talk about the transformations of these. So we're looking at this function right here, and we're going to fill in all these blanks. So the h represents a horizontal shift. Horizontal. There we go. And that would be along the x-axis. K is the vertical shift. Vertical shift, which happens along the y-axis. Now, I should have filled this in first. So we're looking at this. This goes with the horizontal shift. If your horizontal shift is positive, it's actually going to go towards the left. If I can do that better. It's actually going to go off towards the left. And then if it is a negative shift, it would actually go to the right. There we go. So positive would go to the left, negative goes to the right. Now if we're talking about the vertical shifts, if it's positive, it'll go upward. And then if it's negative, it's going to go downward. That one's pretty self-explanatory. The end point or the turning point can always be represented by the letters H and K. So whatever you get for H and K over here, that is where your end point and turning point is going to be. If the A out front, is going to be negative, then the function will be reflected, essentially just flip over. It is reflected across the x-axis. It'll just flip right over the x-axis. If our A is going to be greater than 1, this represents a vertical stretch. And just a reminder, the way I helped you remember this was if you stretch your hands towards the ceiling, your body gets skinnier. So that's a way of remembering a stretch. If your A is greater than 0 but less than 1, this is a vertical compression. This is when the graph is going to get short and fatter. And remember how I use the expression fat bottom girls for vertical compressions, because you're likely going to get a fraction right here. That's how you remember it. Now let's look at numbers 1 through 4 and just explain what transformations are happening in the graphs. So looking at number 1, inside of the radical here, that is where our horizontal shift is taking place, and it is a -7. So since it's negative, it's actually going to go towards the right. It's going to go to the right by 7. And we also have this +2 outside of the radical. So not only will it go to the right 7, but it will also go up by 2. Let's look at number 2 now. So we have this 4 out front, and that represents the A. That's definitely going to be bigger than 1. So since the A is greater than 1, we're going to have a vertical stretch. I'm just going to put VS, vertical stretch by 4. There's nothing inside the radical, it's just the X, so there's no horizontal shift. But we have the -1 outside, so then it's also going to go down by 1. So vertical stretch by 4 and down 1. Looking at number 3, don't miss the negative that they got right there. We have a negative out front, so that means it's actually going to be reflected. So I'm going to go ahead and just put reflection. So, and it goes over the x-axis. There's not an option where it's going to flip over the y-axis. So just put reflection. And then now looking inside the radical, we have x plus 3. And so since it's positive, it's actually going to go towards the left 3. Going to the left by 3. And something to make a note of, I'll even do it in a different color. So right here where it has a positive, x plus 3, this is actually being written as x minus a -3. That's important to keep in mind as we move forward with this. So just tuck this somewhere in the back of your brain. So moving on to number 4, we have 1/2 right here out front as our A, and since it's bigger than 0 but it's less than 1, this is actually going to be a vertical compression. So I'm going to put VC, a vertical compression by 1/2. Oops. There we go. Now looking inside of the radical, we have x minus 2, so it's going to be negative. So it's actually going to be going towards the right by 2. And last but not least, we have the -6 outside the radical. So then it's also going to go down by 6. Alright, now for numbers 5 and 6, we're actually going to be drawing the equation. So they list out all of the characteristics up here, so let's read carefully. So we have a square root parent function, okay? It's being reflected across the x-axis, so we're going to need a negative somewhere. It's being shifted 7 units to the left and 1 unit down. What is that equation going to look like? So of course we need f of x equals, we're going to need a square root. I'm going to try and draw it pretty big. So there's the first thing, we've got our square root. It's being reflected across the x-axis, so based on our notes over here, we need a negative sign right here out front. So there we go, there's the first 2 underlines. Being shifted 7 units to the left. So if we're having a horizontal shift to the left, we're going to need a positive sign. So in this case, I'm actually going to have x plus 7 inside of the radical here. And remember, because then that would actually look like x minus a -7. Something to keep in mind for later. And lastly, it's going 1 unit down. So if it's going down, then it's going to be negative right there. So minus 1. That's our equation. Now let's look at number 6. We have a cube root function, a little different. It has a turning point located at -2 and 3. And remember, the turning point is always represented by h and k. And let's write our equation here. So f of x equals, and there's no reflection here, so we're not going to have a negative. So I don't really need to put room, but I do need a cube root. So our turning point is -2, 3. -2 is going to be my h here. Let's go ahead and put the x. And that's where this little thing I've been telling you is going to come in handy. So this -2 right here, it's going to go there, but it's going towards the left. So, it's being shifted to the left since we have that negative right there. So we're actually going to end up having x minus a -2, which of course, because it's double negatives, would just end up becoming a positive there. That's why I've been telling you this the whole time. And then last but not least, we got that +3 with the k, and that's going to go right there outside the radical +3. When it comes to the k value or the vertical shift, that makes the most sense. With the positives and the negatives, that one actually lines up. But the h's, the horizontal shift, that one is always opposite sign. That's why it's kind of tricky. But this is what our function is going to look like. And that's all there is to it.